Hi, in this video we will learn what is an antiderivative of given function. So far, what we learned was that when someone gives you a function, if the function is nice, it means differentiable, you can differentiate it and find its derivative. So the operation here is called differentiation, yes? Now we want to do something which is the reverse of this thing. Someone gives us a function and we're trying to find a function whose derivative is the given function. So such that the derivative of the function we find is equal to the given function. This is what is called anti-differentiation. And let me start with the definition of what is an antiderivative. A function, capital F, is called an antiderivative of f, lowercase f given function, on an interval I, or on a domain, if the derivative of the capital X is equal to the lowercase f. So we are looking backwards. So we are trying to find a function whose derivative is given function. We are not differentiating. For example, function, what is antiderivative of x cubed? Well, means what? Means that give me a function such that when I differentiate, I get x cubed. Well, since the power is 3, so such a function needs to have power 4, such that when we differentiate, we go one less power, it will be x cubed. But differentiating x to the power 4 will give us a coefficient 4. To get rid of that 4, I need to multiply this by 1 over 4. So x4 over 4 is antiderivative of x cubed. x4 is an antiderivative of x cubed. How about function like f of x equals to 1 over x? Well, what is the function whose derivative is 1 over x? Well, we know that this is the famous function ln x on the interval. Actually, the interval we consider here is 0 to plus infinity. If you like, on negative infinity to 0 also we have a function whose derivative is 1 over x, and that is ln of absolute value of x. Well, another example, trig function f of x is sine x. What is antiderivative of sine x? In other words, what is the function such that when you differentiate the function, you get sine x? Well, cosine x is a good candidate, but remember that the derivative of cosine x is minus sine x. To get rid of that negative sign, we have negative cosine x. So negative cosine x is an antiderivative of sine x. So you have to always be careful not to confuse anti-differentiation by differentiation, and this is one of the good examples that show you have to be very careful. Okay, Now, there is a question here that is antiderivative unique? So if I give you a function, is there only one antiderivative for that function or more than one? Is antiderivative of a given function unique? So is there more than one or just exactly one? Well, let's just do the simple examples of f of x cubed, then the antiderivative that we found is a capital F is x4 over 4. So the derivative of this function is x cubed. To be honest, this is not the only one, because I can have, for example, x4 over 4 plus a 1. The derivative 1 is 0, so the derivative of this guy is also x cubed. Or I can have x4 over 4 plus 2. And indeed, I can have x4 over 4 plus any constant c. And well, that shows that, well, the answer is no. And we know that just by this simple argument, we know that if f, capital F, is an antiderivative, derivative of f, then f x plus c for any constant c is also an antiderivative of f, as we had seen. So this is why when you're trying to find antiderivatives, you should put always plus c, because at least you know that well, all such a things are also antiderivatives of the function. Well, you can go a little bit further and ask, is this the only way we can generate antiderivatives? And a theorem says, yes, this is the only one you can generate. Indeed, if f is antiderivative of lowercase f, for any constant c, fx plus c is, these are the only, or the only antiderivatives of f. So this forms all the antiderivatives, meaning what? Meaning that you find one antiderivative, then plus c, you have found all the antiderivatives of that function. Well, this is the notion, the introduction of the notion. We will learn a little bit more about these things, and we will use it later in the integration.